Okay, I know this says group problem solving, and you're like, this is a video on YouTube. It totally is. It totally is. But find a group. Ask your friend, ask your dog. Come on, bring somebody along. Rubber ducks work usually pretty well. I got nothing around me right now. Oh well. Fireplace is with me, okay? I've got a fireplace in front of me. Mr. Fireplace will help me out. Okay, so what do we have? Well, we have a sandbag. It's dropped from a balloon that's ascending vertically at a constant speed of 6 meters per second. Okay, so initially it's going 6 meters per second. That would be my V naught. Bag is released with the same upward velocity of 6 meters per second, t equals 0, and hits the ground when t equals 8 seconds. Ooh, okay, so I know how long it takes to get to the ground, but how high up was it? So we want to know the speed of the bag as it hits the ground and the altitude of the balloon at this instant. So as a note, this is not asking for how high the balloon was at the beginning, but the altitude of the balloon at the end. How are we going to do it? Integrals and derivatives. Integrals and derivatives. And also remember that our acceleration is constant, which means we get to use our constant acceleration equations because there's no other forces here. We just have 9.81 meters per second squared pushing us down, and it tells us the balloon is ascending at a constant speed, so it actually has no acceleration. Bag does, though. Okay, so the bag is released when t equals 0 seconds, and it hits the ground when t equals 8 seconds. So, I know that my initial position for the bag is some number. I don't know what it actually is, but I'm trying to calculate for it. And I'm going to say that the ground is 0. So, now look here. This is where you have to be careful. Notice how it's a negative 6 right there, and the acceleration is positive? The reason for this is we're saying that down is positive, okay? Down is positive. We're trying to figure out how far it has fallen. So I am doing my datum like this. Here's the ground, down here. And I'm going down to the ground, okay? I'm going down to the ground. This is 0, this is S. That's what I'm trying to find out right now. Now, this is just my constant acceleration equation. I know everything in it, but my V naught was negative because it was initially going up, and I said that down was positive. If that confuses you, that's completely fine. Just make up positive and down negative. And your number will be a negative, but it's the same. I'll just have negative 265.9. No issues. Just be careful with how you do it. I plug in my time, 8 seconds. I plug in my acceleration, which I know, which is 9.81 meters per second squared. And I solve. So this is how far the bag fell. But it didn't ask me for how far the bag fell. It asked me how high is the balloon at the end. So the balloon started at this, but it continued up at 6 meters per second for 8 seconds. Well, 6 times 8 is 48. So if I add those together, I get that it's at 314 meters. So the balloon kept on going up. Here's the balloon to begin with. There you go, little thing. It went up to here by the time the bag hit the ground. And there's our answer. We've got it. It's done. Happy days. So, oh, I had to find out when the bag's velocity too. Sorry. More to this problem. I thought I was done with the problem. Goodness. So once again, this is our constant acceleration equations. I'm just trying to find the velocity of the bag. I know what it is initially, and remember we're saying that it's negative 6, that's going up is negative. And so at the end it has a velocity of 72.5 and down, because if you think about the velocity of that bag, it would look something like this with time. So this will be velocity right here, this would be time. So at 0 it's negative 6, and it is going to be slowing down. Got to be very careful with this. It'll go something like this. There we go. So it's slowing down as in it's getting less and less negative until it hits 0. That's when it's more or less, from looking at its position, it would look something like this. And it comes back down again. So that's where it's 0. That is the initial velocity of 6. And then finally, when it hits the ground, that's equal to 72.5 going down. So that is what's happening here. And all I had to use was my constant acceleration equations. So I plug in my velocity. That's negative 6. I plug in my time, and I have an answer. Cool. So that should do it for now. I think that's everything. Yes, let the learning continue, and I'll see you all next time. Have a good one. Bye-bye.